Everyone, in this video we're going to go through the probability progress quiz, which covers sections 8A to 8G of the textbook. So 25 questions, some of them quite challenging, so it would be a good idea when we go through this video, or when you listen to this video, that you actually annotate and take away key ideas and add them to your bound book, especially if you got a question wrong. If you got a question right, just make sure you still take note, because it may have been a while since you've looked at that question and you may have forgotten, or maybe you guessed and you guessed correctly, which is awesome, but guessing isn't always going to help you, so you need to know how to do it. All right, let's start. So question 1, a coin is flipped twice. What is the probability of obtaining one head and one tail? Give your answer as a percentage. All right, so with a coin, you could have either a head or a tail. Now, you could do this with a tree diagram, but tree diagrams are quite time consuming. And this sort of question, it would be a good idea just to think about, well, what are the different possibilities? So we want just one head and one tail. So that means you could have either a head and then a tail, or a tail then a head. All right, so they're your only possible outcomes. And if you did a tree diagram, you would get them. All right, so to get a head, it is 1/2. And then to get a tail, it is also 1/2. So that gives you 1/4. And it's the same for tails and heads. All right, so we get 1/4 and 1/4. Now, if you think of this in terms of a tree diagram, and I would picture this in my head as a tree diagram instead of drawing it, when you're going along your branches, you multiply. All right, so that's why we did the 1/2 times 1/2. And then when you've got multiple outcomes like we do here, so we've got, this is your first outcome and this is your second outcome, you're adding them together. So 1/4 plus 1/4, and you can use your calculator for this if you want to, is 2/4, which is 1/2. So as a percentage, it's 50%. All right, let's keep going, because that was probably an easy question. All right, question 2. A bag contains a certain number of red, blue, and yellow marbles. So I'm just going to underline that as we go. A marble is drawn from the bag and then replaced. So it's important that you note whether it's replaced or not, because that can change your probability. The results of repeating the experiment 50 times are shown in the table below. All right, so you can see red is obviously more frequent than blue and yellow. What is the experimental probability of selecting a blue marble? So experimental is what actually happens. If we had did something in theory, all right, that would be theoretical probability. So if we had, say, the same number of red, blue, and yellow, it would be 1/3. All right, would be your theoretical probability. But we're doing the experimental. So what actually happened in this experiment? So we've got 50 times and we had 10 blue. All right, so 10 over 50, and you should simplify that so that becomes 1/5. All right, question number 3. Sorry, PDFs are always less user-friendly than a Word doc. All right, a bag contains a certain number of red. Oh, this time, okay. I was like, I thought I just did this question. All right, very similar question. Red, blue, and yellow again, and it's also replaced, and we're doing it 50 times. We are looking at the experimental probability again. All right, and it hasn't actually told us how many red, blue, and yellow marbles there are. So we can't actually do the theoretical probability, only the experimental probability. All right, so this time we want a red or a yellow. So we could add them together. So we've got 23 over 50 plus 17 over 50, which gives you 40 over 50. Or we could just do 1 minus what we don't want, which is blue, and we get 4/5. All right, so both, either way you get 4/5. All right, question number 4. A card is chosen from a standard deck of 52 playing cards. What is the probability of selecting a king or a queen? So we've got 52 cards. All right, so that means it's going to be out of 52. And you should have a copy of a deck of cards. So you should know in a deck of cards, you've got 4 kings and 4 queens. So you've got 4 plus 4. 4 kings, 4 queens. So 8 over 52. Now, you should be able to simplify that on your calculator, or if you don't have your calculator, just think about, well, what's the highest, sorry, I can't even think, the highest common factor. All right, the highest common factor is 4, but let's say you didn't know it was 4. You can see that they're both even numbers. So I could simplify it to 4 over 26, and then that simplifies to 2 over 13. So if you're ever sitting there thinking, what is the highest common factor? All right, you just need a factor. You just need a common factor. All right, if you can't think of the highest one, because sometimes you could be sitting there forever thinking, what's the highest common factor? Sorry, let's try to do this a bit quicker. There we go. For an event A, the complement of A is defined as all elements in A, but not in any other set. Oh, this is interesting. For an event A, the complement of A, all right, is defined as all the elements in A, but not in any other set. All right, well, no. For an event A, the complement is defined as all the elements in A. Well, it's not. It's all the elements that aren't in A. So that's false. Bit of a weird question, the wording there. But understanding the complement is not A. You got A, and then the complement of A is everything but A. All right, a group of people were tested for allergy A and allergy B. If a group member is selected at random, what is the probability that the person has at most one of the allergies? Give your answer as a simplified fraction. So a group of people were tested for allergy A and B. Group member is selected at random, that the person has at most one of the allergies. All right, so we want to do the probability as well. So this means you have an allergy. So you either have at most one. Oh, I know what it would be if it was at least one, at most one. All right, well, let's just do it. So if you had allergy A, so the probability of A would be 16, 21 over, how many have we got? 21, 29, 30, 40. And then the probability of B is 13 over 40. And we only want one, at most one allergy. So we can't have these 5. All right, so we're going to do the probability of only A, which I probably should have done in the first place. So we want A and not B, which is 16 over 40. And then the probability of B and not A is 8 over 40. So together we have 24 over 40, and we could have done that straight from looking at the diagram. 24 over 40, and simplifying that, what is that, 3 over 5. All right, so just to recap, this inequality, at most 1. Oh, actually, I've just realized you could have none as well. So 3 out of 5 means you have 1 allergy, but you could also have no allergies. So we've got to add that on. So 24 over 40 plus no allergies. Okay, so 35 out of 40, which is 7 over 8. And we could have done 1 minus what we didn't want. All right, that's a bit of a tricky question just with the wording, and probably overcomplicated it a little bit by calculating all those other probabilities. So basically we didn't want that 5 in that I've already scribbled out. All right, question 7, using the two-way table below, find the probability of not A. So not A is 8, so it's 8 over 12, and you do need to simplify that fraction. So the highest common factor is 4, so it's going to be 2/3. All right, just keep scrolling. Two events A and B such that blah, 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 blah. Find the following probabilities. All right, so you could do the addition rule. I think we might need to do the addition rule to complete a two-way table. So let's find the probability of A and B first of all. So using the addition rule, I'm just going to write it down. All right, so we've got the probability of A is 0.38, probability of B is 0.46, and A or B is 0.67. All right, I'm just going to do that on my calculator because I'm very tired. I'm not functioning too well today. All right, so we've got 0.38 plus 0.46 minus 0.67, 0.017. All right, and then the probability of not A and not B. Let me just scroll down here. So if we wanted to, we could do this on a two-way table. Or we could just do, I'm just thinking. Yeah, so if we've got the probability of A or B is 0.67, the probability of not A and not B would be 1 minus that. But I also want to show you on a two-way table because I'm a huge fan of two-way tables. All right, so we've got B, not B, and A, not A. All right, so just filling that in, we've got 0.38 and 0.46 here. And then we did 0.17. Remember, they all have to add up to 1. So basically, we want this value here. So we can just complete our two-way table. And I'm going to be slack and use my calculator just so I make sure I've got the right values. What's that going to be? 0.3. 3. I didn't use my calculator, hopefully it's right. So, and we can see which is the same as doing 1 minus 0.67. You would also get 0.33 that way. All right, scrolling along. Find the probability of A if probability of B, A or B, and A and B. So here, again, you're going to use the addition rule, which I wrote up here. Up the top. So let's just fill it in. So we've got 0.1. I'm not going to rewrite the addition rule. Probability of A is what we want. So let's just call it X. Or you could write probability of A if you want. Probability of B is 0.4. Probability of A or B is 0.8. And basically now we're just solving for X. So X is equal to 0.1 minus 0.4 plus 0.8. What is that? 0.4, 0.5. All right, and again, you can do that on your calculator if you needed to. All right, question 10. 140 students attend a school camp. 45% of the students were girls and 25% of the students were under 16 years of age. 55 boys were aged 16 or over. How many boys aged under 16 were at the camp? Okay, so let's just do a two-way table because, again, I'm a huge fan. So we can have, well, because we're focusing on boys, let's just do boys, not boys. And we want under age of 16, so under, not under. So effectively, I mean, we didn't have to do do it that way, but we're wanting how many boys aged under 16 were at the camp. So we want this value here. All right, so we've got 140 students in total. So 45% of them were girls. So I'm just going to take 45% of 140. So that's 63. So that means that 77 were boys. 25% of the students were under 16. So that's 35. 55 boys were aged 16 or over. So that's going to be 55. So yeah, that's going to be 22. Alrighty. So just doing your percentages. So what I did on my calculator for to get the 63, it's just 140 times 0.45, which is the same as if you did 45 over 100. So just converting that percentage to a decimal. All right, question 11, complete the two-way table below and find the associated values. All right, so remember your rows have to add up. So that's going to be a 4, that's going to be an 8, and that's going to be a 20. All right, so n, remember, is your number. So number of not x and not y is this one here, which is 5. And the probability of x given y. So we're looking at y, which is 7, and then how many of them have x, which is 3. So 3 over 7. So conditional probability formula, you can read it straight from a two-way table. If not, that if you didn't know, x given y is the probability of what they both have in common, and then probability of y. All right, so question 12. A card is drawn from a standard deck of 52 playing cards. Find the probability that the card is an ace, given that it is a red card. All right, so again, you can do conditional probability formula. So, but your denominator is how many red cards there are. So half the deck is red and half is black. So you got 52 cards, so 26 are red. How many of those red cards are aces? There's 2, so that simplifies to 1 over 13. All right, question 13. 30 musicians are surveyed to find, 30 musicians are surveyed to find out which instruments they play. It is found that 18 play the flute, 11 play the cello, and 7 play both. Find the probability that a musician selected at random from the group plays the flute, given that they play the cello. All right, so we can have flute, not flute, cello, not cello. All right, two-way tables, I just reckon are the best. All right, we've got 30 musicians, so 30 goes there. 18 play the flute, 11 play the cello, and 7 play both. We want to know groups plays the flute given that they play the cello. So we don't even need to complete the two-way table. So we're looking at the total number that play the cello, which is 11, and how many of those 11 play the flute? 7. All right, so 7 over 11. You could complete the two-way table if you needed more information. Again, the conditional probability, what gives that away is the phrase given that. So we basically want the probability of C and F, or F and C, over the probability of C, which gives you 7 over 11. Which is the same, you don't have to do the probability as doing the n, because the denominators actually cancel each other out. All right, for the events A and B, probability of A equals 0.7, B 0.2, A given B equals 0.4, probability of A and B. So let's just do the conditional, hold on, do I need the conditional? All right, let's write the conditional probability formula quickly. So all right, so A given B is 0.4. A and B is what we want, and B is 0.2. So X is going to be 0.4 times 0.2, which is 0.08. Again, you could do that on your calculator. We did not need the probability of A. All right, question 15. Two six-sided dice are rolled and the numbers showing are multiplied together. Complete the table below. Oh, you probably already have this in your notes. All right, so we should have 16, 20, 24, 20, 25, 30, and then 24, 30, 36. All right, two cards are selected from a standard deck of 52 playing cards. The cards are chosen without replacements. Remember, that's important, changes the probability. Find the probability of selecting both black aces in any order. Simplify your answer. All right, so with your deck of cards, the black are basically your clubs and your spades. So you have two suits. So you only have ace of clubs and ace of spades. All right, so they're your two cards. Now, if we were doing this, let me just quickly do it. Two cards are selected from a standard deck of 52 playing cards. The cards are chosen without replacement. Find the probability of selecting both black aces in any order. All right, so we can have all right, I'm just thinking of the best way to explain this. So the ace of clubs is only one of them, 1 over 52, and the ace of spades is only 1 out of 52 for them. Now, if our first one was ace of clubs, all right, that's going to be 1 out of 52. And then if we wanted the ace of spades, there's only one of them, but we've got one less card. All right, so we're going to multiply them together. And we'll do that on the calculator. Then it could be reversed, but the outcome is actually going to be the same. So if we did the ace of spades first, it would be 1 over 52. And then if we had the ace of clubs second, it would be 1 over 51. All right, so you can see it's the same. So I'm just going to do it on the calculator 2 times that, because it's the same thing. 1 over 52 times 1 over 51. It's wanting it as a, oh God, 1 over 1,326. So let me just, so that I'll just finish this. So 2652, 2652. So adding them to get, hold on. Yeah, adding them together gives you 1 over 1,326. All right, 2 students are selected at random from a class of 14. All right, so 2 class of 14 to receive awards if each student is equally likely to be chosen and the same student cannot receive both awards, in how many different ways can the two awards be given? All right, so if you think of this as a table, so we've got 14 students, and we could have all 14 along the top and the 14 down the side. So we've got 14 here and 14. So if we were looking at the number of outcomes in here, we would do 14 times 14, which is 196. Now, they can't receive both awards, so we're going to take away the fact that they can't receive both awards. So, and that's going to be 14. So remember when we did these questions in class, it was the diagonal. You couldn't have those diagonal values. So it's going to be 196 minus 14, which is 182. So if they could, think of it in terms of if they could receive both. So I think the question we did in class, they could get a distinction and a merit. All right, so 14 students on the top for the distinction, 14 on the side for the merit, and then all the different possibilities in your table, which would be this part here. All right, so that's 196 outcomes, and you wouldn't actually write them all because it's ridiculous. But we don't want that diagonal because they cannot receive both awards. So we're going to take that away. So 182 different ways they can be given. Alrighty, so you would have just noticed a whole bunch of scribble just came on the screen because I did this question. I've just checked my answers. This one I got wrong because I did not read the question correctly. I was rushing through it. I don't know why I did not read it correctly because it makes sense to be asked this question as opposed to how I interpreted it. So I use both words together. So let's just ignore all that working out. I can't actually delete it. So let's do the question properly. And I wanted to leave my incorrect thinking there to show you how easy it is to read a question incorrectly and therefore get it wrong. So this one I read incorrectly. It was the only one I got wrong, which was good because I hate making errors and then having to edit the videos, which is what I'm doing now. All right. So a letter is chosen from the word Cambridge, and then a second letter is chosen from the word university. I actually combined the two words. So if you can have a look at my scribbled out tree diagram, I realized there were 19 letters in total, added up all the vowels, instead of treating them as separate words. So for Cambridge, there are 9 letters, of which 3 are vowels. So we've got 3 out of 9 because we want to know the probability of selecting 2 vowels. So a vowel from the word Cambridge, 3 over 9, and then a vowel from the word university. We're going to multiply them times 10 because it's 10 letters and there's 4 vowels. Now, if you were doing this by hand, you would simplify your fractions. So 3 over 9 is 1/3 and 4 over 10 is 2/5. So the answer should be 2 over 15. So again, I wanted to keep that incorrect working out just to re-emphasize the importance of reading a question properly. All right, bye guys. Oh, and sorry, continue on. All right, question 19. 2 marbles are drawn without replacement from a bag containing, so we need 2 marbles, 4 yellow and 8 blue. We've got without replacement. If the first marble drawn is yellow, what is the probability of drawing a blue striped marble on the second selection? All right, 2 marbles are drawn without replacement. All right, let's do a tree diagram again. So yellow, blue, yellow, blue, yellow, blue. All right, so we want, if the first marble is drawn is yellow, what is the probability of drawing a blue striped marble on the second selection? So we've got 4 yellow, so 4 out of 12. And then we want the blue. So if we've taken a yellow, there's still going to be the 8, but now the number has reduced to 11. So it's going to be 8 over 11. We don't have to complete that tree diagram because all we want to know is this probability here. We already know we've got a yellow, so it's reduced the number of marbles by 1, but the number of blue has not changed because we only took out a yellow. All right, keep going. John chooses a tie at random to wear to work each day. He has 6 solid coloured ties and 9 striped ties. Oh, let's use the same letter, guys. All right, note that his ties are replaced in the drawer each evening and he can wear the same tie on consecutive days. All right, so we've got with replacement. Calculate the following probability. So SSS. So he's got, so the probability of 1S, so 6 over 15, which we'll simplify that now, is 2 over 5. So if you've got SSS, that's 2 over 5 times 2 over 5 times 2 over 5, which is the same as 2 over 5 to the power of 3, which is 8 over 125. All right, so we want S, not S, not S. Well, S, so solid, striped, striped. So we want 2 over 5ths for the solid, and then striped is 9 over 15, which is the same as 3 over 5. So it's going to be 125. What's that? 3, 9, 18. And does that simplify? I don't think so. 18. I'm just going to check on my calculator if it simplifies, because we do need to put it in simplest form. Okay, 18 over 125. All right. Consider the Venn diagram below. Are the events A and B independent? All right, so for independent events, excuse me, we've got the formula probability of A and B is equal to the probability of A times the probability of B. So that just tests whether they're independent. So we've obviously got no context here, but we can just use this formula. So A and B, so that's this intersection here. So 1, and we're writing them as probability. So what have we got? 10. 1 over 10. Probability of A is 5 plus 1, which is 6. So 6 over 10 times the probability of B, which is 3 over 10. And I can already see that's not going to be 1 over 10. It's going to be 18 over 100. So no, not independent. All right, C and D are independent events. So again, we're going to use this formula that we used up here. So if they're independent, we're just going to multiply them together. So 1/4 times 5 over 6. So 1 times 5 is 5. 4 times 6 is 24. So 5 over 24. All right, A and B, two events such that. All right, so here we can use, I prefer the conditional probability formula. It's standing out to me. We did a question like this earlier. You could use it. Oh, it doesn't say that they're independent. So you've got to use the conditional probability formula. So the conditional probability formula is A given B is equal to the probability of A and B over the probability of B. So A and B is 0.15. Probability of B is 0.6. Was that 1/4, I think? Let me just check. Oops. Yeah. Now it probably wants it as a decimal, so 0.25, because it hasn't got the space there to write 1/4. All right, find the value of x so that the events A and B are independent. All right, so the total is 7 plus 2, which is 9, plus 14, which is 23. So 23, so the total is equal to 23 plus x. All right, so if they're independent, so again, we've had that formula up above, so I'm just going to do that here. So 2 over 23 plus x is equal to probability of A, which is 9 over 23 plus x times 16 over 23 plus x. And I'm just going to use solve on my calculator. All right, and I get 49. I think it'll be so high, but anyway, let's keep moving on. All right, and last question. Find the value of x so that the events A and B are independent. Okay, so we're going to do the same thing. So in total, what do we got? 12, 19. 19 plus x, so 4. 11 over 19 plus x times 12 over 19 plus x. All right, so just using solve on the calculator. All right, and I get 14. All right, so just using solve. I'm not going to get the calculator up and running, and I think that was the last question. All right, good work, guys. Some hard ones in there. Just make sure you take some notes. Bye.